All right, guys, up on the screen, you guys can see what the deal is for tomorrow. If you guys are going to be home tomorrow, you'll be watching the day 12 notes I'm going to put together later on today. But if you're in class, you'll get a paper copy of the quiz, and that's what you can expect. 9 questions, 25 points. All of it involves sine, cosine, tangent. All right, and again, I put Pythagorean theorem down because, hey, we are dealing with right triangles. Yes, we're dealing with right triangles, so Pythag's always an option. You just won't see Hills and Sass. You won't see 30, 60, or 45, 45, 90 triangles. All right, so most of it, sine, cosine, tangent. You may have to deal with a little Pythag, but that's it for tomorrow. And then, like I said, if you're not taking the test, you'll be watching the day 12 video and submitting your notes as homework credit. Tomorrow, my plan, just so you guys know that are coming into school tomorrow, my plan, I am going to go over the homework with everyone like I usually do. You guys will submit it, then I'll give you the quiz. Okay, so you guys that are coming in tomorrow, I'm still checking homework. All right, still checking it. And it's still due tomorrow for everybody. Any questions or concerns? I will be after school today if you want to get specific with anything. Angle of elevation, depression, find an angle, find a side, whatever floats your boat. Okay? All good? I'm not going to go over too much here. That's about it. In addition to this, in addition to what I have up there on the screen, I did put one question that regards today's notes. All right, today's notes is brand new material. And yes, I did put one question on tomorrow's quiz that pertain to those notes. I need you to do something for me first before we hit up the notes. You guys in class, you're going to have one job. You guys at home have another job. So I got my right triangle up here. Here's what I'd like you to do. Everyone's going to find x, side x, to the nearest whole number. You guys in class, you go from 27 degrees. Use 27 degrees. You guys at home, use 63 degrees for me and find x. All right, this is how I'm going to lead into today's notes. All right, and this is not found in anybody's notes. Just write down a little sine, cosine, tangent equation, solve it for me real quick, and then so we can talk. All right, this isn't located in your notes anywhere. This is just something I decided to do today to get you guys introduced to today's notes. So jot down a sine, cosine, tangent equation. You guys in class, you have to use 27 degrees. You guys at home have to use 63. All right, here we go. So hopefully I'll pick one person from in class, one person at home to help me out. First up, here we go. 1-7, Maeve, ready? So you went from 27 degrees. What'd you pick, sine, cosine, or tangent?
Sine.
Sine, good call. So you did sine of 27 equals x over 32. And what'd you get to the nearest whole number? 15, good job. All right, so we got 15 in class. All right, you guys at home that use 63, what did you use? Oh, got it. Look at that. Ellie, what'd you use?
I use cosine.
All right, I like it. Cosine of 63 equals x over 32. And what did you get for your answer, Ellie?
I got 15 too.
Whoa. Hold on. Wait a second. We all got the same answer. People in class use sine. People at home use cosine. And they use two different angles. And still got 15. How is that even possible? Grab your calculator right now. Here's why it's possible. Everyone go ahead, do the sine of 27 and take a peek at that decimal right now. Sine 27. And then right underneath it, do the cosine of 63. Ho-ho! What do we notice? They're both the same values, right? And we both multiplied them by 32, so our answers, yeah, should have came out to be the same. Look at that, guys. The sine of 27 was the same thing as the cosine of 63. Wow. I wonder if that works for other pairs of numbers. I wonder. Let's find out. Now we can go to the notes. Let's see. What's that whole relationship about? Sine and cosine always being equal. All right, so instead of putting side lengths down on triangle ABC, you guys see I've labeled them side length X, Y, and Z. First thing I'd like you to do, can you guys write the ratio for the sine of A? Sine of A using X, Y, and Z for me, please. Find the sine of A using X, Y, and Z. So what's the ratio of sine A? Jeez. Caroline, what do you got for me?
Y over Z.
Good job. It's Y over Z. Ooh, this is going to challenge you now, honors kids. The second question. Find me another one that comes out to be Y over Z. And what I mean by another trig function is sine, cosine, tangent of this angle. All right, find another one that comes out to be Y over Z. Challenge yourself now. Maybe it's not challenging, but I think it is. All right, did you find another one that would come out to be a ratio of Y over Z? There you go. Sabrina, did you find another one? Yep. Cosine of B, the right angle. I think you meant cosine. You have cosines, good, but not from B. Cosine C, there you go. Cosine of C. Everyone agrees? Adjacent over hypotenuse. Hey, whoa! Again, what just happened? The sine of one angle was equal to the cosine of another one. Again, I just showed that to you here. Sine of 27 and cosine of 63 were equal. Oh boy, there's got it. Okay, let's try to figure this out now. What's going on between A and C? And this might be a tough one here. This might be a tough one. Put it away. Oh, never mind. That's not me. I thought you were doing phone issues. A and C. What do we got? What's the relationship between A and C in that diagram? And some of you may get it, some of you may not. This is a tough one. Anybody see the relationship between A and C? Go ahead, Radhika.
Is the sine of one of them congruent to the cosine of the other one?
It is, but I'm trying to figure out angle A by itself and angle C by itself. Do they relate to each other anyhow? Angle A and angle C. Is there any relationship between the two? Anybody at home think they want to take it? Zach, you think you got it?
Are they complementary?
What's complementary mean again? Remind us.
They equal 90.
Do they add to 90? How many degrees in a triangle?
180.
180. Take away angle B, the right angle. How many degrees do I have left? 90. So yes, all right. Angle A and angle C are complementary. Wait, hey! $27 and 63. Anybody? What do you know about them? Yeah, darn right. So basically, when are sine and cosine going to be equal? When I know what about their angles? Their angles have to be what for sine and cosine to be equal? Add up to 90. They have to be complementary. And that's exactly what we're going to write in our little conclusion here. Here we go. If angle A and angle B are complementary. No, I'm just doing in general. Okay? I'm not going based on the diagram anymore. If angle A and angle B are complementary, Not going off the diagram anymore. This is just a general conclusion. Then, ready? The sine of one of them, A, is going to be equal to the cosine of the other. And again, I could flip A and B too here, remind, all right? I could say sine of B. Actually, why don't we just do that too? Or sine of B is equal to the cosine of A. But again, I'm going to stress this too much probably today. The angles have to add up to 90 for sine and cosine to be equal. For sine and cosine ratios to be equal, the angles you take have to add to 90. Ready? Watch. Here we go. I'm going to just use your usual quick calculator work. Who's 8 here? Ryan, quick question. Can you just give me a random acute angle, please?
45 degrees.
No, give me another one.
33 degrees.
33. So everyone ready? Cosine of 33. Not too sure what decimal that is, but I can guarantee it's going to be the same value as the sine of, what do you got for me? Why 57?
Because 57 plus 33.
If sine and cosine are going to be equal, the angles have to be complementary. All the time. And you want to check it on your calculator right now, go ahead and check every time. Okay? Audrey, give me another random acute angle.
47.
Sure. Sine of 47. It's equal to some decimal, but I can guarantee that decimal is going to be the same as the cosine of 40.
Do you still want me to do it?
I don't got anybody.
43.
Then 43.
43. Yep. Everyone picking this up, how this works with sine and cosine. Because I'm going to kind of go a couple different types of questions that you'll see. Again, one question that regards all of this on tomorrow's quiz. All right, here we go. So you guys can do numbers 1 and 2 pretty quickly. Find something that's equivalent to cosine of 20. I know I don't want the decimal written out. Just write another sine tangent one that's equal to the cosine of 20. 2. So here we go. Hannah, what do you got? Sine of 70. Again, why did she pick 70 in particular? Because they're complementary. It's complementary to 20. How about the sine of 37? Give me something that's equal to the sine of 37. 11. Here we go. Anthony, give me something that's equal to the sine of 37.
Cosine of 53.
Good job. Cosine 53. They both have the same value. Nice job, Anthony. Questions so far? We're all right? All right, let's get a little bit Let's go get nuts now. I don't like the wording of number 3. I'm going to actually add in something here. So if you could add it in too. If x and x plus 20 are the measures of 2 acute angles in a right triangle. All right, and then just because they're 2 acute angles, they got to be in a right triangle. And the sine of one of the angles is equal to the cosine of the other angle. What's the value of x then? And I get it. You guys look at it, and the habit you guys probably already in is I'll set x equal to x plus 20. Yeah. Then you just didn't see what I just did this whole class. When are sine and cosine equal? When I know what about x and x plus 20? They have to be what? Complementary. So instead of setting them equal, I'm going to add them up and say they're complementary, equal to 90. Why? Because I know the sine of x is equal to the cosine of the other angle, x plus 20. And the only time that happens is if those two angles are complementary. And now we can have something nice and easy to solve for x. X equals 2, 5.
If you were given just the part before with if x and x plus 20 are the measures of 2 acute angles in a right triangle,
Yep.
if you were given just that, could you assume that they're sine and cosine, or?
See, that's like if you just have 2 acute, like I could give you 2 acute angles, but they don't add to 90.
It's 35, yeah.
Oh, it's 35. Sorry, yeah, settle down. So that's why I needed to put in that right triangle. Because just because I give you two acute, I could give you 20 and 40. But sine of
Well,
x.
when they be in, I don't know, I guess they're in the right triangle. I thought they would be.
But since they're in a right triangle, I know those two acute angles have to add to 90. So, all right, next up. Let's see if we're really picking this up or not.
I have a question.
Yep, go ahead.
Would it have to say that sine of x equals cosine of x plus 20, or could you just like do the same thing but without that information? Like if you knew it was in a right triangle and there were two acute
Yeah, I got you.
angles.
Yep, it would have to equal 90. Yeah, I got you. Yep. So I could get rid of the sine and cosine. And
Okay,
you're
yeah.
still good. Yeah. All right, 4. In triangle ABC, angle C is the right angle. If you want a visual of it, if you want a right triangle, go ahead. Here's angle C is the right angle. And you got A and B. Take a look what I give you. Cosine of A is equal to radical 21 over 5. So what's the sine of B? Well, what do you know about A and B? They're complementary. So if A and B are complementary, what do I know about the cosine of one and the sine of the other? If A and B are complementary, guys, if I know the sine, the cosine of one is equal to the sine of the other. So what's got to be sine of B then? Here we go. Let's roll. 13. Sophia, what do you think here? What's got to be the sine of B?
Radical 21 over 5.
Also radical 21 over 5. Yep. And I always want to show you this visually too, instead of just going back to the conclusion we wrote down. Take a look. If cosine, remember cosine is adjacent over hypotenuse. So AC would be radical 21 because it's adjacent. 5 would be AB because it's hypotenuse. And then now look, if you're doing sine of B, which is opposite over hypotenuse, everyone see where I'm still going to get radical 21 over 5. Opposite radical 21 over hypotenuse 5. Okay, so not even using the conclusion we came up with, I could still do this. All right, what about 5? Cosine of B is 5/13. What else should equal 5/13? So cosine of angle B is 5/13, meaning what else should equal 5/13? What do you think here, using what we've talked about today already? Maeve, what do you think here?
Sin of B. Or no, sin of A. I have no idea. Wait.
The answer was fine. It's your language.
Oh, sign.
Yeah, thank you. Sine of A. Anybody else hear that at home? Sin? How long have we been doing this? Sin? Jeez. Sine of A, yes. Any issues yet? We got 2 more quick ones, and then you can get going on your homework. 10 minutes. All right, here you go. I know, I get it, guys. It's so easy just to set them equal to each other and go. And I'm going to guarantee that choice is probably listed as well for you to circle. But hey, you see sine and you see cosine are equal to each other. If sine and cosine are equal, automatically that tells you those two angles are not equal, they are complementary. That's the only case where sine of an angle and cosine of another one are equal. The angles are complementary, not equal to each other. Maybe I'll get this one right. 25. Okay, so we're picking this up a little bit. If you see sine and cosine equal, angles have to be complementary. All right, last one. This really cements it if we know what the heck's going on. Another right triangle with a right angle at C. All right, I'm telling you, the sine of A ratio is increasing. What's happening to the cosine of B ratio then? The sine of A, whatever ratio that is increasing. It's getting bigger. So what's happening to the cosine of B then? Think about the relationship. What do I know about sine of A and cosine of B? Anybody at home want to take this? These guys here have been chatting away today. It's not a bad thing. Anybody at home want to take this?
It would decrease
Ooh, why?
because since they're complementary, they both have to add up to
Oh,
90.
no. Whoa. A and B are complementary. Now I'm doing the sine of A. So that ratio, Audrey, you're thinking about angle A by itself and angle B by itself. But I'm saying the sine of that angle. Okay? You're taking just angle A and angle B by itself. So yes, you would be correct. But I'm talking about the sine of angle A now. And the cosine of angle B. Not just the angles by themselves. What do I know about that relationship there? There was a... So now I gotta click on this, wait for it to open. What's that mean? They'll never catch me. What is that? What is that?
Simpson did something illegal, but they'll never prove it.
Oh, okay. Radhika?
Wouldn't it like go up?
What do you know about sine of A and cosine of B? Sine of A, cosine of B are the same values. Right? They're the same values. So if sine of A goes up, what? B has to go up to match it, right? So increases. Because I'm just going to write the same thing there. Sine of A is equal to the cosine of B. So if one goes up, the other's got to go up too because they're equal to each other. Kyla, go ahead.
How would you increase the sine of A?
How would I increase?
Without changing the angle.
Yeah.
I could change without, okay, so let's see. I could change the sides. Like if I say 12 over 13.
Oh, I was gonna say, 'cause if you.
Okay, now I could increase that by saying 12, I wouldn't say 12, but I could go 13 over whatever, 20 here. Increase
Like
that
if you have
ratio.
similar triangles.
What's that?
Like
Yeah,
if you have-
okay.
That makes sense.
Remember, it's not the angle I'm increasing, it's the ratio I'm increasing. Okay? Anybody else? Questions, concerns? So one of these will be, not one of these exact problems, but a problem like this will be on the quiz tomorrow using sine and cosine and then being equal to each other. All right. Part of the homework is what we just did, but the other part is review. So take it seriously, please. All right, there are some review questions I threw in there to get you ready for tomorrow. So go ahead and start attacking.